Hello everyone, this is Mrs. Jarima. We are going to look at how to simplify radicals. So the first thing that you really need to know, and you need to know well, you need to know your perfect squares. So if you don't know your perfect squares very well, make a list on the side of your paper and know that if you're on a test or a quiz, if you make this list on the side of the paper for yourself, it might help you out. So we know that 1 times 1 is 1, so the square root of 1 is 1. We also know 2 times 2 is 4, so the square root of 4 is 2. Okay, so if I keep on making this list, these right here would be my perfect squares. So 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, and then we have 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. So we can keep going as well. 11 times 11 is 121, and then 12 times 12 is 144. You should also know that x squared is a perfect square because the square root of x squared is x. So x times x, right? Also know x to the fourth is a perfect square because x squared times x squared is x to the fourth. So any even number over here as an exponent is going to be a perfect square. So another one, x to the sixth, because x cubed times x cubed is x to the sixth, and so on. Okay, so you can keep going with that list. So let's look at some problems and keep that perfect squares list over here. First problem I'd like to take a look at is how to simplify the square root of 18. Now I'm going to show you two different ways. You can pick whatever way you're comfortable with. So the first way that we're going to look at the square root of 18 is to break this down into prime factorization. Okay, prime factorization means I'm using prime numbers to multiply to get 18. So let's take a look. What can I multiply? What two numbers can I multiply to get 18? Well, 9 times 2 is 18. Okay, 2 is a prime number, but 9 is not because I need to break down 9 to 3 times 3. Now 3 and 2 are both prime numbers. So I have my prime factorization here that I know the square root of 18 is equal to the square root of 3 times 3 times 2. 3 times 3 times 2 is 18. Okay, so you can see here that these two match. So if you think about that, 3 times 3 is 9. I know 9 is a perfect square. 3 squared, because the exponent is even, is a perfect square. So what is the square root of 9? So I'm just breaking this down. Okay, 3 times 3 is 9. And then I have 2. So I can break it down like this. 9 times 2 is still 18. So the square root of 9 is 3. And then we have the square root of 2 left, which is not a perfect square, so we're going to leave that. So my answer to the square root of 18 is 3 square root of 2. Okay, so there's the first way that we learned how to do the square root of 18. We do the square root of 18 again, but this time we're going to look at it a different way. This time I want you to think to yourself, what perfect square goes into 18? What is the highest perfect square that goes into 18? Well, I'm going to look at my list here. Okay, 1, of course, 1 does. 4, does 4 go into 18? No. But 9 goes into 18 twice. So I'm going to rewrite the square root of 18 as the square root of 9 times 2. So square root of 9 times 2 can be broken down into the square root of 9 times the square root of 2. and the square root of 9 is 3, and the square root of 2 is as reduced as we can get it. So again, 3 square root of 2. So two different methods that you can use to find the square root of any number. Okay. Okay, let's try another one. Let's take a look at the negative square root of 48. So we have this negative in the front. That's basically negative 1 times the square root of 48. So let's break down 48. What perfect square goes into 48? Well, I'm going to start dividing. Okay, find the highest perfect square that goes into 48. Well, I know 4 will, but that would be 4 times 12. And I know that 4 goes into 12 as well, so that's not the highest one. I'm going to keep checking. Okay, so then you can do the next one, 9. That didn't work. How about 48 divided by 16 is 3. So we have 16 and 3. 16 is my perfect square. Okay, here it is right here. 16 is a perfect square. So I'm going to break that down into the square root of 16 times the square root of 3. Don't forget that negative still in the front. Okay, so the square root of 16 is 4. And then we have the square root of 3. There's your simplified answer. Okay, there's one. Why don't you try the square root of 180? Okay, so now we have our perfect squares list. Now let's take a look at fractions. So we have the square root of 8/9. So what we get here is the square root of 8 over the square root of 9. Know that you can break it up that way. So at the top, square root of 8. What perfect square goes into 8? I know that 4 does. So that would be 4 times 2. I also know that 9 is already a perfect square. The square root of 9 is 3. So let's break down the top. The square root of 4 is 2. And I have the square root of 2 left over. And then we have 3 on the bottom. That is your simplified version there of square root of 8/9. Okay, you try the square root of 7/16. Okay, on our perfect squares list, this time at the bottom, I did put the perfect squares with variables just to kind of remind you that if it has an even exponent, it is a perfect square. So let's take a look at our first problem. We're going to reduce the square root of 12, x squared, y to the third. Okay, so first of all, let's think, what perfect square goes into 12? Well, 4 does. 4 times 3. So I'm just going to break this all down. Remember, x squared is a perfect square because x times x is x squared. So I know x squared is a perfect square already. And then we have y to the third. Now if we break this down, y squared and y to the first would break down to y to the third. So you have to remember you'd be adding these exponents together. So that would add to 3. So I can break down y into a perfect square, y squared, and then y to the first, which is what was left over after I took y squared out. Okay, so now let's simplify this. Remember, it's all under the radical sign. And each piece of this can be broken down, if that helps you to remember that each part is separate. Alright, so let's identify our perfect squares. We have the square root of 4, which is 2. still have a radical here because I know I have 3 left over, so I'm going to put that back under the radical. Okay, then we have the square root of x squared. The square root of x squared is x, because x times x is x squared. And then I have y squared, and the square root of y squared is y. And then what's left over? I have 3 and y that are not perfect squares. So there you are. You have 2xy times the square root of 3y. Okay, one more that we're going to try. So we have 2 times the square root of 32, x to the 5th, y to the 6th, and z. So the first thing I want you to remember, this is 2 times whatever is under the radical there. So 2 times the square root of 32, x to the 5th, y to the 6th, and z. So we're going to focus on what's under the radical first and break that down. So I want to look at 32. What perfect square goes into 32? Well, it should be 16. 16 times 2. Okay? Then we have x to the 5th. Well, x to the 5th, that's not a perfect square. X to the 4th is a perfect square because that would be even. And then I would have a leftover x to the 1st. Okay? Next thing we have is y to the 6th. Y to the 6th, that is an even exponent, so that is going to be a perfect square. And then we have z to the 1st, which is not. So remember, all of this is under the radical sign. Okay? And let's take a look at our perfect squares first. Square root of 16 is 4. And I know that 2 will be left underneath the radical. So I have that. X to the 4th, square root of x to the 4th. Remember, x to the 4th is the same as x squared times x squared. So the square root of x to the 4th is x squared. And then we have x to the 1st, which will be left under the radical because it's not a perfect square. Y to the 6th, so y to the 3rd, because y to the 3rd times y to the 3rd is y to the 6th. Remember, you're adding these together. And then we have z to the 1st left over, so z is left underneath the radical. The last thing we need to do is bring down that 2 that was being multiplied. So this should be 2 times 4x squared y to the 3rd. So we end up with 2 times 4 is 8. So 8x squared y to the 3rd, and the square root of 2x times z. So this would be your final answer. If you're still listening, please put a star at the top of your notes.